All right, let's get started. So we were discussing problem sheet number 6, right? All right. So we were on question number 4. So before we move on to the next problem sheet, let's quickly finish this off. Okay. So let's do question number 5 now. Question 5. The solution of the equation 5z plus 7 by 2 is equal to 3 by 2z minus 14. Of course, the idea is to bring the variable to one side and bring the numbers to the other side. But there are fractions that are involved in the question. Okay, so you just need to be careful with the fractions, that's all. So this is 5z minus 3 by 2 z is equal to minus 7 by 2 minus 40. Cool. So this is 5 minus 3 by 2 times z is equal to minus 7 by 2 minus 14 by 2. So this is 10 by 2 minus 3 by 2. I'm sorry, here it's not 14 by 2, it's 14 into 2 divided by 2. So this is going to be minus 7 minus 28 divided by 2. So this will be minus of 7 plus 28 whole divided by 2. So this is minus 35 divided by 2. Yes. Yeah. So this becomes 10 minus 3 by 2 into z, that is equal to minus 35 divided by 2. So this is 7 by 2 is equal to minus 35 by 2. Now your 2 gets cancelled, 7 gets cancelled, and it becomes 5. So your z value is minus 5. Minus 5. All right. So in the solution given to you, there is some mistake. There is some calculation mistakes. So do rectify it. This is the actual answer. And if you have, see, when you're doing these kind of problems, it is always good to go back to the original question, substitute and verify. Okay, that'll give you more practice. So always go back to the original question. So original question is, the first step is 5z plus 7 by 2 is equal to 3 by 2z minus 14. So you can go back and substitute and see if it is actually being satisfied. So this is minus 25 plus 7 by 2. And the RHS is minus 15 by 2 minus 14. So this is minus 50 plus 7 by 2. And here we have minus of 15 by 2 plus 14. So minus of 15 plus 28 by 2. So this becomes minus 43 by 2 is equal to, here we have minus 43 by 2. Yes. So that is being satisfied. So our answer is right. Cool. Our answer is right. And I've told you one more thing. This is fine, right? This is fine. You okay? Now I've told you in the beginning itself you could have got rid of the fractions. How can you get rid of the fractions? You multiply the entire expression with the common denominator, the lowest common denominator you can think of. So 5z plus 7 by 2 is equal to 3 by 2z minus 14. So multiply the entire expression with 2. Here also multiply the entire expression with 2. So we have 10z plus 7 is equal to 3z minus 28. Now there are no fractions to deal with. So we have 10z minus 3z is equal to minus 7 minus 25, which is minus 35. And the LHS we have 7z is equal to minus 35. So we have our answer as minus 35 divided by 7, which is minus 5. Got it? So this is quicker if you can think this way. Just remember to get rid of the fractions. And for that, you have to think about it's not always easy to find the lowest common denominator. In this case, there is just one number in the denominator, which is 2. There is just one number in the denominator, right? It is 2. And the other number is always 1. Okay. So it makes sense to multiply the entire expression by 2, right? I hope you're getting my point. Yes. Yeah, cool. So let's move on to the next question, which is problem number 6. Question number 6, we have x is equal to 4 by 5 times x plus 10. Okay, here, although it may look like there are fractions involved, it's actually a problem involving cross multiplication. You know, the RHS is actually 4 into x plus 10 divided by 5. And the LHS is actually x by 1. Right? So when you have something of the form a by b equal to c by d, what do? You just cross multiply. We have a into d is equal to b into c. That is the idea. So 5x is equal to 4x plus 40. Cool. So 5x minus 4x, x is equal to 40. Yes. So here you have to think about cross multiplication. You have to think about cross multiplication. Right? You have to think about cross multiplication. If you had thought about fractions, it would have been lengthier. This method is fine for you. You got this method. You got the idea. Now, suppose if you had thought about fractions. So let's say you have x is equal to 4 by 5 into x plus 10. Now you're thinking that you have to deal with fractions. So you, on the RHS, you expand using distributive property. So 4 by 5 times x plus 40 divided by 5. Okay. Now you bring everything x to one side. So you have x minus 4 by 5 times x is equal to 40 divided by 5 is 8. So we have 1 minus 4 by 5 times x is equal to 8. So we have 1 by 5 times x is equal to 8. So x is equal to 5 times 8, which is 40. This is slightly more lengthy, right? Yes or no? This is a little more lengthier, right? So you do realize that a lot of problems can have multiple approaches. You do realize this, right? Mm-hmm. Yes. And in the exam, in your school exams, the idea is to write as many steps as possible. But in an SAT, the idea is to arrive at the answer in the shortest time. Okay, so you have to write minimum steps as possible, as minimum steps as fast as you can do, right? But how do you know? I mean, how do you know which approach to use? How do you know? How do you know whether to go with this approach or go with this approach? How do you get this logic? How do you get this logic? What do you think? How do you get this logic? See, that comes through practice, okay? That comes through practice only. There's no other magic. So that's why I'm reiterating on doing a lot of questions, doing a lot of problems, okay? All right. So if we solve a lot of problems, definitely during the exam you will be able to like recall which method to use for a particular problem, right? Next question. The solution of the equation, we are doing 7, okay? 2u divided by 3 plus 1 is equal to 7u divided by 15 plus 3 is. So we have 2u divided by 3 plus 1 is equal to 7u divided by 15 plus 3. So you can deal with fractions right away. You can do that. You can deal with fractions right away. You can do that. Otherwise, you can get rid of fractions as well. So let's deal with fractions in the first method. So we have 2u by 3 minus 7u divided by 15 is equal to 3 minus 1. So we have 2 by 3 minus 7 by 15 times u is equal to 2. Now, what is the least common denominator you can think of? In the LHS, we have 3 and 15. 3 and 15. What is the least common denominator you need to come up with? See, you have 3 and 15. 3 and 15. So what is the least common denominator that you will come up with? That'll be 15, right? Because, this 15 is 3 into 5. So in the numerator also, you multiply with 5. Make sense? Make sense? Yes. So our common denominator is 15 now. So we have 10 minus 7 times u is equal to 2. So we have 3u divided by 15 is equal to 2. And 3 and 15 gets cancelled off. So u is equal to 10. U is equal to 10. Yes, this is cool. Yeah, I hope we have already done this question. Okay, in the second approach, you may want to multiply the entire expression on both LHS and RHS with a number so that this denominator will go away. You have to make sure that the denominators go away. So which number will you multiply on both LHS and RHS? Which number will you multiply with? Please tell me. Which number will you multiply with on both LHS and RHS so that the denominators go away? Tell me. Yes, 15. Very good. 15, right? Because the denominators, when you look at them, we have 3 here, 1. It's 15 here, and it's 1 here. So we have various kinds of denominators, which are 3, 1, and 15. And you have to think of a common multiple of all this. A common multiple of all this. Right? So the first common multiple that you can think of is what you want, which is 15. You could have taken 30 as well. You could have taken 45 as well. Okay, but we are always looking at the least common multiple. We are always looking at the least common multiple. So multiply with the least common multiple. Got it? Others, Prisha and Robin, you do understand that, right? Yes. So you multiply with 15 on both sides. We have 15 times 2u by 3 plus 1 is equal to 15 times 7u by 15 plus 3. So we have 15 into 2u by 3 plus 15 is equal to 15 into 7u by 15 plus 15 into 3. See, in the beginning, this might look cumbersome, but look at this. The denominator is gone now. The denominator is gone now. You are left with simple numbers. 10u plus 15 is equal to 7u plus 45. Bring everything to one side. We have 10u minus 7u is equal to 45 minus 15. So we have 3u is equal to 30. U is equal to 10. Cool. So let's go to the next question. Shall we? Yeah. So which is question number 8. Question number 8. The solution of the equation 2u by 3 plus 1 is equal to 7u by 15 plus 3 is. No, that is done, right? That is what the 7 is done. Now it's 8 actually. The solution of the equation 3t minus 2 whole divided by 4 minus 2t plus 3 whole divided by 3 is equal to 2 by 3 minus t. Okay, so this looks slightly more complicated. So let's try to get rid of the denominators. So that is the best approach in this case. Let's try to get rid of the denominator. So you have to multiply with a number. Okay, multiply with a number that will get rid of all the denominators. So denominators are 4, 3, 3, and 1. So what do you think that number will be? The number has to be a common multiple of 1, 3, and 4. It has to be a common multiple of 1, 3, 4. What is the number? What about others? What about others? Yes. Olivia, yes. Yes. Okay, you do understand what a common multiple is, right? Okay, I'll show you a quick example. Say you have 6 and 12. No, 6 and 15. You're looking at the common multiple of, you're looking at the least common multiple. You just call it LCM, least common multiple. I hope you have heard of this term LCM, right? Least common multiple. Least common multiple. Heard of this term? Least common multiple. Heard of this term? In your lower classes, maybe in your pre-algebra or something like that. Heard of this term? Least common multiple, the least common multiple? Yeah. What is least common multiple? Is the smallest number among the common multiples. So, what are multiples of 6? Multiples of 6 will be 6, 12. Then 6 into 3 will be 18. 6 times 4 will be 24. 6 times 5 will be 30. Now it's 36. Then it's 42. Then it's 48. Then it's 54. Then it's 60. And so on. And what are multiples of 15? 1 times 15 is 15. 2 times 15 is 30. 3 times 15 is 45. And 4 times 15 is 60. You keep adding 15. Okay. 75. And so on. Now, can you tell me what are the common multiples from the list so far? from the numbers I've listed down so far, what are the common multiples of the 6 and 15? What are the common multiples of 6 and 15 from the numbers I've listed down so far? Of course, this is an infinite list. These two are, both of them are infinite lists. You have an infinite number of multiples for 6. Now, from the list, from the numbers I have noted down, what are the common multiples of 6 and 15? Yeah, that's cool. What about others? The first common multiple you encounter is 30, right? And the second one is 60. Now you can guess what will be the next common multiple. You can guess what will be the next common multiple. It'll be the next one. The list is incomplete, but you can just guess it, right? Easily guess it. What will be the next common multiple? Sorry. What will be the next common multiple? Without actually writing down the numbers. Yeah, that's cool. Olivia, you're right. What about others? There's a pattern, right? You have 30, then 60, then the next number is going to be 90, right? Right? And we are interested in the least common multiple. And so LCM of 6 and 15 is going to be 30. Okay. And so what is the use of this LCM? That is, one of the uses is like solving equations of this kind. When you have to bring a common denominator, when you have to get rid of the denominators, you have to multiply with a number. So here you have 4, 3, and 1. The denominators are 4, 3, and 1. Now we are looking at the multiples of 4, 3, and 1. And in fact, we are looking at the common multiples of 4, 3, and 1. Multiples of 4 will be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and so on. Multiples of 3 will be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and so on. Multiples of 1 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Now tell me what are the common multiples of 4, 3, and 1? You can list down from these numbers. You can observe from these numbers the common multiples of. So multiples of 4 are listed down, multiples of 3 are listed down, multiples of 1 are listed down. Yes, very good. Yes. The first common multiple you encounter is 12. Right? The first common multiple you encounter is 12. And of course, the next common multiple is going to be 24. Okay, 24 is here, and after sometimes it will be here as well. Right? And similarly, the next one is going to be 36. 36 is here, and after sometimes it will be here as well. Yeah, yes, cool. So we could choose any of these numbers. Yeah, it's basically a 12 table. Yeah, Exactly. Okay. So once you figure out the smallest number, it'll be the tables of that number, multiples of that number. So we have figured out that the smallest common multiple, the least common multiple is 12. You have figured out that the least common multiple is 12. So the common multiples will be 12, 24, 36, 48, and so on, which is nothing but 12 table, right? Now the idea is if you multiply the entire expression with any of these numbers means what? 12, 24, 36, 48. The denominators will go away. But you don't want to multiply with any random number, right? You definitely want to choose the smallest number because that will make your math easier, right? Make sense? You want to choose the smallest number, so that will make your math and life easier. So we are going to choose 12. Make sense? Tell me if it makes sense. So you're going to multiply the entire expression with 12. You're going to multiply the entire expression with 12. So you could have chosen 24 as well. Okay. But we are looking at the smallest possible number so that the math will be much, much easier, right? Okay, cool. So you multiply the entire expression with 12 on both sides. Let's see what happens now. The 12 gets distributed. 12 into 3t minus 2 divided by 4. Now, we are very sure that this 4 will go away. Why? We are sure that this 4 will go away. Why? Because we have chosen the 12 as a multiple of 4. Okay. 12 happens to be a multiple of 4. So we are very sure that this 4 will go away. Yes, again, the next step, we have 12 into 2t plus 3 divided by 3. Now here also we are very sure that 3 will go away. Why? Because 12 is chosen in such a way that it is also a multiple of 3. That is why we choose the common multiple, right? That is why we choose the common multiple. Makes sense, right? 12 is chosen in such a way that our 4 was cancelled off. And here, again, 3 will be cancelled off. You now see, you understand why 12 was chosen, right? You understand why 12 was chosen, right? If we had chosen 8 instead of 12, if you had chosen 8 instead of 12, it wouldn't have done the job. It wouldn't have done the trick. 8 wouldn't do the job, right? Because 8 is a multiple of 4, but 8 is not a multiple of 3. So here you will have a problem. Instead of 12, if you had 8, if you had 8 instead of 12, you still have a problem. Understand? On the other hand, 24 also would have done the job. 24 also would have done the job, but But 12 will anyway do the job, so why go for 24? So that's the idea. Okay. See, 12 is going to do the job anyway. 12 will do the trick for us. So why go for a higher number? We'll stick with the smallest number possible. So that is the idea of choosing the lowest common denominator or lowest common multiple. Lowest common denominator or lowest common multiple. All right. Yes. Now, you don't have to really worry about this because the numbers that you will come across in an actual examination will be small numbers. Okay. Simple numbers. Okay. Numbers you're familiar with, numbers whose multiples, numbers whose tables you're familiar with. Okay. But again, the logic should strike you quickly, and that comes only through practice. And there is no other way around. There is no other shortcut to learn mathematics. The only way to study mathematics or learn mathematics is to do mathematics. Okay. And the RHS we have 2 by 3 into 12 minus 12 into t. So 3 and this is 4. So we have 90 minus 6 is equal to minus of 8t plus 12 is equal to 8 minus 12t. So far, so good. So far, so good. We have multiplied the entire expression with 12. Now the denominators have disappeared. You don't have denominators or fractions to deal with anymore. You're happy now. Yes? Tell me. See, this is not a very difficult thing, okay? Because, in math, everything has a logic. You don't have to blindly memorize or mug up stuff. Do understand that. In math, you don't have to memorize anything. You don't have to mug up anything. You just need to develop that kind of a logic. So we have 90 minus 6 minus 80 minus 12 is equal to 8 minus 12t. So bring everything to one side, bring all the variables to one side, the numbers to the other side. So we have 90 minus 80 plus 12t is equal to 8 plus 6 plus 12. This is cool. And LHS is going to be, if you take t outside, this is going to be 9 minus t plus 12 is equal to, this is going to be 14 plus 12, which is 26. And here it is 1 plus 12. So this is 13t is equal to 26. 13t is equal to 26. And your t values 2. T value is 2. Good. Tell me something good, bad, ugly. Yes, cool. Okay. See, let's go to next question, which is problem number 9. 6x plus 1 divided by 3 plus 1 is equal to x minus 3 divided by 6. 6x plus 1 divided by 3 plus 1 is equal to x minus 3 divided by 6. Again, you don't want to deal with fractions. Okay. You don't want to deal with fractions. There are two ways to approach this question. There are, in fact, three ways. You can deal with fractions. How? If you want to deal with fraction, how will you do it? This is basically 6x by 3 plus 1 by 3 plus 1 is equal to x by 6 minus 3 by 6. Now you have to deal with all the fractions and things like that. Simplify, you get the answer. That is one way to do it. Get it, right? You understand this idea, right? I've split the numerator. So it becomes 6x plus a 6x divided by 3. Next term is 1 by 3. Similarly on the RHS. So you can do this way. We're not doing that. Okay. The second way is, second approach is, as we just discussed, get rid of the denominators. So you have to think of a common multiple of 3, 6, and 1. 3, 6, and 1. So what is the number that you're thinking of? The number that will get rid of all the denominators will be a common multiple of 3, 1, and 6. And that will be a common multiple of 3, 1, and 6 will be. Please tell me. 3 won't do the trick because 3 is not a. Yes, I'm waiting. No problem. Take your time. See, I just want you to get this right because these are pretty much fundamental things. Yeah, 6, right? 6 will do the job. 12 will also do the job, but we are not choosing 12 because we have 6. Why do we go for 12? So you just multiply the entire expression with 6. Let me ask you something. Have you seen these kind of problems in school? Have you solved these kind of problems in school? Have you in which grade? In grade 8, right? When you've done pre-algebra? When you've done pre-algebra or in algebra 1? When was that? Solving these kind of questions is there in your pre-algebra textbook. I have seen that. I'm not very sure whether it's covered in school or not. Just because it's there in the book, it doesn't mean it'll be covered in school, right? So, do you remember which class, which grade you covered this stuff? Grade 8, grade 9, grade 10? 8 or 9, yeah, okay. So this was either covered in pre-algebra or in algebra 1, right? Now, do you realize that there are multiple approaches to a problem now? You understand that there are multiple approaches to a problem? It can be done in multiple ways. So that's our idea here. Yes. Now, the 6 can be distributed. 6 can be distributed. Oh, in the RHS, the 6 directly goes away. Okay. So this directly becomes x minus 3. So here 3 and 6, it's 2. So this is 2 into 6x plus 1 plus 6 is equal to x minus 3. So we have 12x plus 2 plus 6 is equal to x minus 3. So we have 12x plus 8 is equal to x minus 3. Bring x to this side. We have 12x minus x is equal to minus 3 minus 8. So we have 11x is equal to minus 11. And your x is minus 1. X is minus 1. Got it? I have a request. So when we are solving a problem, when I'm working out, please make a note of it. Okay. I hope that you have a pen and paper with you. Make a note of it. Or I don't know whether you're using an iPad or something. Just make a note of it. Because you have to actually work out with your pen and paper and get the real practice out of it. Just by staring at the screen, just by staring at the book, just by reading up, you won't be able to do maths. Trust me. Okay. So when you're intending to do math, when you're trying to do math, always pick up your pen and paper. Please do not try to read up stuff. Please do not try to watch things, view things, because that way you can't learn math. You can learn maths by actually doing stuff. Okay. Always make it a point to write down stuff. Okay. Cool. So far, so good. Yes. And one more thing. So this was the second approach we talked about. Second method we talked about. Okay. Another method is cross multiplication. Okay. I'll tell you what cross multiplication is. We have already seen a problem that was done using cross multiplication. See, how can we do using cross multiplication? See, 6x plus 1 plus 1 is equal to x minus 3 divided by 6. Now, in this question, see, forget about both LHS and RHS. Focus on just one side. Okay? Focus on just one side. Focus on just one side. Forget about both LHS and RHS. In the earlier case, we are thinking about all the denominators which were present on both LHS and RHS. We were looking at 3, we were looking at 1, we are looking at 6, and then we were thinking about a common multiple that will get rid of all the denominators present on both LHS and RHS. Okay. So in this approach, we are not bothered about the RHS for the time being. Let's just look at the LHS. Okay. In the LHS, see, I'm going to set things right. I'm going to make a common denominator here. So obviously we have 1 and 3. I'm going to make the common denominator as 3. Okay. How? You just multiply this with 3 and 3. Your common denominator is 3 now. So this expression is going to be 6x plus 1 plus 3. Yes. So in this case, the idea is to focus on just one side, and convert it into a fraction. where you have the common denominator appearing. Okay, instead of having just two numbers or two fractions, just make it into just single fraction. Just single fraction. Yes. So this becomes 6x plus 4 divided by 3. And RHS in this particular case, there is nothing to be done because it is already in the fraction form. Okay. Otherwise, you have to do the same approach on RHS as well. You have to do the same approaches on RHS as well. So here in this case, there's nothing to be done on RHS because it's already in the fraction form. So that is equal to x minus 3 divided by 6. Now we are ready to cross multiply because we have converted the expression into a by b equal to c by d form. Right? So our idea was to convert it into a by b equal to c by d form. Our idea was to convert it into a by b equal to c by d form because if you have that form, you can easily cross multiply both sides and simplify it. Right? Yes. Now you just cross multiply. But before cross multiplying, see whether you can cancel off some terms. Can you cancel off some terms? Yes, you can. You have 6 here and 3 here. So I'm just canceling 3 and 6. It'll be 1 here, 2 here. Now you just cross multiply. So we are done with, we are left with 2 into 6x plus 4 is equal to 1 into x minus 3. So we have 12x plus 8 is equal to x minus 3. Again, the same math. We have 12x minus x is equal to minus 8 minus 3. We have 11x is equal to minus 11. And your x is minus 11 divided by 11, which is minus 1. Cool. So this is the third approach. Tell me if it's fine. Makes sense? Yes. Yes. All right. So let's go to the last problem of the sheet, which is question number 10. So we have m minus m minus 1 divided by 2, whole divided by 2 equal to 1 minus m minus 2 by 3. See, one thing I want you to notice, when somebody writes this minus of m minus 1 by 2, what is that meaning? This negative symbol, the negative number, the negation applies to the entire fraction. The negation applies to the entire fraction. Okay. So if somebody tells you negative of 5 by 2, what does it mean? Negative of 5 by 2, it means what? The negation is applied on the entire fraction. So this could be written as negation of 5 divided by 2. This could be written as 5 divided by negation 2. Right? You do understand this idea, right? Yes. Yes. So this could be written as negation of m minus 1 divided by 2 as well as m minus 1 divided by minus 2. But we usually use this approach. Okay. So for this reason, it is always better to write a bracket here because you don't miss out that there is a negative sign lying outside and that needs to be distributed. Okay. My point is, even if the original question doesn't talk about a bracket, that bracket is understood there because, this minus is going to go to the numerator. And in the numerator, you have two numbers, two terms. So the negative, when it goes to the numerator, it is going to get distributed. So for safety, so that you don't forget, it is always safe to put a bracket there. Even if nobody is telling you, even if the question doesn't talk about a bracket, it pretty much makes sense to write a bracket in the first place. Cool? Write a bracket, parenthesis, so that you don't make a mistake. Yes? Understand, right? See, the idea is simple. Idea is simple. This is minus of m minus 1 by 2. Even though this negative is applied to the entire fraction, we know that it can be written as this negation can be applied to the numerator. Okay. Since there are two numbers in the two terms in the numerator, the negation will go to both the terms. That will be distributed because each will get its share. That will be distributed. So in the original question, it is not given. They have not talked about a bracket, but it is understood that there's a bracket here. So always make it a point to write down that bracket, because otherwise you might make a mistake. You will give that negative sign to m only, but it is not that way. It doesn't work that way. The negation goes to the entire numerator. The negation goes to the entire numerator. Okay. So I have written it in the first step itself because a future error can be avoided. Yes. Now again, there are three approaches. One approach is you just split the denominator. So we have minus m by 2, and then negation of negation is plus 1 by 2. What have I done? I split the numerator. Okay. 1 minus m by 3, then it's 2 by 3. See, we don't want to go with this approach because we don't usually like fractions, right? Our idea is always to get rid of fractions. We don't really like fractions, do we? No, we don't, right? So we won't do this approach. We won't go this way. So instead, there are two approaches we talked about. One is think of the common denominator of the entire terms. There is one here, one here. So if you look at both LHS and RHS, the denominators are 1, 2, 1, 3. And then you multiply the entire expression with the common denominator. And that number will be, you multiply the entire expression with the common denominator. The number will be, tell me what will be the number? What will that number be? I'll take 2 more minutes. What will that number be? You understand what I'm saying, right? I want to multiply the entire expression with a number so that all the denominators on both LHS and RHS just go away. Yes, that number is going to be 6 because we have 1, 2, and 3 as the denominators. And the common denominator, common multiple of these numbers is going to be 6. Common multiple of these numbers is going to be 6. What about others? What about others? Yeah. So one approach is multiply the entire expression with 6. Okay. That is one idea. Okay. Otherwise, as I mentioned in the previous problem, don't look at both sides. Just look at one side. Focus on just one side. On the LHS, we have just 1 and 2. So make the common denominator as 2. Okay. How? You just multiply this with 2. Multiply this with 2. So this becomes 2m minus m minus 1. And similarly on the RHS, we have 1 and 3 in the denominator. So make the common denominator as 3. So we have 3 minus m minus 2 by 3. Okay. So this is a third approach we are talking about. First approach was about fractions. The second approach is multiplying the entire expression on both LHS and RHS with 6. Okay. And the third approach is cross multiplication, in which you just focus on LHS and RHS separately. And the idea is to convert the LHS into a fraction, RHS into a fraction. Convert it into this form. Now you can cross multiply. Right? Now you can cross multiply and do the math. Got it? Now you can cross multiply. First of all, simplify. This is 2m minus m plus 1 by 2. And this is going to be 3 minus m plus 2 by 3. In the next step, it is going to be m plus 1 by 2 is equal to 5 minus m divided by 3. In the next step, you cross multiply. So this becomes 3 into m plus 1 is equal to 2 into 5 minus m. Now we have 3m plus 3 is equal to 10 minus 2m. Now simplify as usual. Okay, got it? So this is the cross multiplication approach. In the cross multiplication approach, what do? You convert both sides into this forms. Yes, but working out L separately on both LHS and RHS. And the other approach is you convert the entire expression sans denominators, without denominators. Okay, for that you multiply with the common multiple of all the denominators, which was 6 in our case. All right. So that's it. We are done with problem sheet number 6. In case you have any clarification required in any of the sheets we have discussed so far, we'll continue in the next class. Meanwhile, we have a pending sheet number 7, that is to be discussed. I hope you've gone through that. Gone through that sheet. Have you gone through sheet number 7? Yes or no? Yes. Okay. So we'll discuss that tomorrow in the next class, and we'll also go to the next topic where we will discuss about word problems and things like that. See, these are normal math, normal problems. Then now we'll see in the next step, we'll see word problems, which needs to be converted into math problems. English needs to be converted to math first before solving it. Okay. So we'll see that in the coming classes. Cool. See you then. Goodbye.